Okay, Wildcats, today we're in 8.2, graphing simple rational functions assignment tutorial. Question 1 of 15. Describe how the graph of g of x is related to the graph of f of x equals 1 divided by x. When g of x equals 1 divided by x plus 3. Now, before we graph g of x equals 1 divided by x plus 3, we need to know what the asymptotes are, okay? So, we see here that x equals 0 is our asymptote, because if we set the denominator equal to 0, x equals 0, and then y equals 3 is our asymptote. Okay, so what we want to do before we graph g of x is graph our asymptote. So x equals 0. Okay, so we have our asymptote right here. Okay, and then y equals 3. Now, why that asymptote is important is because we now know that our points lie between those asymptotes. Okay, so now let's graph using our calculator. So I'm going to go to on, new document, add graph, and I'm going to do 1 divided by x plus 3. I'm going to press Control. Actually, before we do that, we might be able to get the points using just the grid. So I'm going to go to Menu, Escape, go to Menu, View, Grid, Line Grid. Okay, I'm going to move this down, and I want to see if that point right here and here, and it looks like that point is 1, 1, 2, 3, 4, so 1 comma 4. And it looks like this point right here is negative 1, 1, 2. So negative 1, 2. We're going to use those points, okay? So we have our points 1, 1, 2, 3, 4. Okay. Now we know our curve lies between the asymptotes, okay? So okay. And now we know negative 1, 2 is our point right here, and that tells us that our curve lies between these asymptotes. Okay. So there's your graph. Okay. All right. Now, step 2, look at the graph and determine g of x relates to f of x. The graph of g of x is a translation of the graph of f of x up 3 units. All right. Let's go ahead and finish. All right, and go on to question 2. All right, question 2 of 15. Describe how the graph of g of x is related to the graph of f of x equals 1 divided by x. Okay. Now, the graph of f of x is graphed, and now let's look at g of x, okay? So we set the denominator equal to 0, so we have an asymptote at x equals 0, and there is no plus value, so that's plus 0, so we know that y equals 0 is our asymptote, okay? So we have x equals 0, and y equals 0. Okay. All right, so now let's graph this, and we need to find points between the asymptotes. Okay, so I'm going to press Tab, up, and I'm going to delete this, and then I'm going to type in 4 parentheses 1 divided by x, press Enter, and it looks like we have a point right there, so that's 2, 2. So we point at 2, 2, and we have a point at negative 2, negative 2. Okay, so let's graph those points. Okay, so 2, 2 is right here. Okay. All right, and then 2, or I'm sorry, negative 2 is right here. And there's your curve right there. Okay. All right. Look at the graph and determine how g of x relates to f of x. The graph of g of x is a vertical stretch of the graph of f of x by a factor of 4. All right. Now that we've finished 2, let's move on to the next question. All right. Again, describe how the graph of g of x is related to the graph of f of x equals 1 divided by x when g of x equals 1 divided by x plus 1. Okay. So we have g of x Now, you ask yourself, what do you add to 1 to give you 0? Okay, well, the answer to that is -1. So, x equals -1 is your vertical asymptote, and then there is no plus value, so it's plus 0, so y equals 0. Okay, so now let's graph our asymptote. So, -1, okay, and y equals 0. Okay, all right, and let's graph this in calculator. Tab, we're going to delete this, and then we're going to do, we can actually do control divide 1 divided by x plus 1. And it looks like we have a point. You always want this point right here, okay, and there. So that looks like we have 0, 1 is a point. And then this point looks like -2, -1. Okay. All right, so just aligning a little bit. There we go. Oh, wait, that's too bright. There we go. Wait, one more. There we go. Now, like so, we have a point 0, 1 is right here. So remember, our curve lies between the asymptotes. Okay. All right, and then we have -2, -1's right here. Okay, and there's our curve. All right, step 2, look at the graph and determine how g of x relates to f of x. The graph of g of x is a translation of the graph of f of x, left 1 unit. All right, go ahead and finish up question 3. All right, question 4. Describe how the graph of g of x relates to the graph of f of x equals 1 divided by x. When g of x equals 1 divided by 0.2x. Okay, we set this equal to 0, so our asymptote is x equals 0. And then there's no plus value, so it's just plus 0, so y equals 0 is your asymptote. Okay, so all right, so now let's graph this in here. So tab, delete this, 1, and actually you probably just do control divide 1 divided by 0.2x. And it looks like, so here's problematic, is that point's not exact, and neither are any of those. Okay, so let's look at the table. Control T. Now we know 0 is undefined, so we should use a point to the left and to the right of that asymptote. So we can use -1, -5. You want to point to the left and to the right of the vertical asymptote. And the vertical asymptote is at when x equals 0. So let's use the point 1, 5. All right, so 1, 1, 2, 3, 4, 5. And then remember, the curve lies between these asymptotes, so that comes there. and it's going to come down something like that. And then -1, -5, so -1, -5. There you go. All right. Step 2, look at the graph and determine how g of x relates to f of x. The graph of g of x is a horizontal stretch of the graph of f of x by a factor of 5. All right, let's take a look at the next. All right. Question 5. Describe how the graph of g of x is related to the graph of f of x equals 1 divided by x. G of x equals 1 divided by x minus 4. Okay, so let's graph that. Okay, so we set the denominator equal to 0. Well, that's easy, just x equals 0. And then the asymptote is this number right here, so y equals -4. Okay, so x equals 0. And I forgot to put the numbers, but that's pretty simple. We can add that. This is 0, 1, 2, 3, 4, -1, -2, -3, -4. And then this is 0, 1, 2, -1, -2, -3, -4, -5. Okay. So the asymptote of x equals 0. And then y equals -4. Okay, and let's graph this. Control T to get rid of the table, tab. Oh, if that ever happens, just press escape, and then go back there. Control divide, 1 divided by x minus 4. All right, so it looks like we have a point is 1, 1, 2, 3, 1, -3. And then we have a point -1, 1, 2, 3, 4, 5. So -1, -5. Okay. So 1, -3. So 1, -1, 2, 3. So since that point lies between the asymptotes, we know our curve lies between there. Okay, and then -1, -5. So -1, -5 is right here. And we know our curve lies between the asymptotes, so here. Okay. All right, now let's take a look at step 2. The graph of g of x is a translation of the graph of f of x down 4 units. Let's do the next question. All right, question 6 of 15. Describe how the graph of g of x is related to the graph of f of x equals 1 divided by x. All right, so we have g of x equals 1 divided by x minus 8. Now you ask yourself, what do you subtract from 8 to give you 0? The answer to that is x equals 8. And then the plus value is plus 0, so y equals 0. Okay, so you have an asymptote at x equals 8. And I forgot to number these. So let's do that now. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's where this asymptote is. Okay, and then y equals 0. 0, 1, 2, 3, 4, -1, -2, -3, -4. Okay, let's go ahead and graph and find our points. So tab, delete this. Control divide, 1 divided by x minus 8. And then it looks like we have a point at 9, 1. And then this point looks like it's at 1, 2, 3, 4, 5, 6, 7, negative 1. Okay. All right, so 9, 1 is right here. So that means our curve is right here. And then 7, negative 1 right here. That means our curve is right here. All right, step 2, look at the graph and determine how g of x relates to f of x. The graph of g of x is a translation of the graph of f of x, or right 8 units. All right, let's go and look at the next question. All right, question 7. Describe how the graph of g of x is related to the graph of f of x equals 1 divided by x. So let's go ahead and graph. Okay, well, we said the denominator goes to 0, so that's x equals 0, so our asymptote. And then it's plus 0, so y equals 0. Okay, so this is 0, 1, 2, 3, negative 1, negative 2, negative 3. This is 0, 1, 2, 3, negative 2, negative 3. And y equals 0. Okay. Now let's go ahead and graph that. So tab, control, divide, negative 0.5, parentheses, control, divide 1 divided by x. Okay. Now these aren't exact points, so let's go control T. Now remember, our asymptote's here, so we need to pick a good value between. Unfortunately, the best values we're going to have is 1, negative 0.5, and negative 1, 0.5. Sometimes you can't get one number, so you have to use the best decimal you can. So 1, negative 0.5 is right here. So our curve is right here. And negative 1, 0.5 is right here. So then our curve is right here. Okay. Step 2, look at the graph and determine how g of x relates to f of x. The graph of g of x is a vertical compression of the graph of f of x by a factor of 0.5, as well as a reflection of the graph of f of x across the x-axis. All right, go ahead and finish up 7. Let's take a look at 8. All right, describe how the graph of g of x relates to the graph of f of x equals 1 divided by x. Okay. So let's graph g of x. Now you ask yourself, what does x have to be to make the denominator 0? Well, the answer to that is 0, because negative 8 times 0 is 0, so x equals 0. And then plus 0, so then it's y equals 0. All right, so our asymptotes are 0, 1, 2, 3. Let's just add the number scales here. 0, 1, 2, 3. Negative 1, negative 2, negative 3. So our asymptotes are at x equals 0 and y equals 0. Okay, so let's graph this. So control T, get rid of the table. Tab, delete that. Control, divide 1 divided by negative 8x. All right, and it looks like, again, we're going to have to use decimals. So press Control T. We know our asymptote is at 0. So it looks like the best we can use is negative 0.125 and here. So we have 1, comma, negative 0.125 and negative 1, 0.125. Okay, so you're just going to have to approximate. So 1, negative is here. You just have, we know it's between 0 and 1, so we can just approximate it. So the curve is here. And then negative 1, 0.125 is, again, we're just approximating, which is right there. And we know our curve is right here. Okay. Step 2, look at the graph and determine how g of x relates to f of x. The graph of g of x is a horizontal compression of the graph of f of x by a factor of 1 divided by 8, as well as a reflection of the graph of f of x across the y-axis. All right, we're going to finish up question 8. All right. All right, question 9 and 15. Identify the transformations of the graph of f of x equals 1 divided by x that produces the graph of the given function g of x. Then select the graph of g of x by applying the transformations to the asymptotes x equals 0 and y equals 0 to the reference point -1, -1, and 1, 1. Also, enter the domain and range of g of x using inequalities, set notation, and interval notation. All right, so g of x equals 3, parentheses 1 divided by x plus 1 minus 2. Step 1. The transformations of the graph of f of x that produce g of x are vertical stretch by a factor of 3, and that's because of the number right there. A translation of 1 unit to the left, which is right here, and 2 units down is right here. All right, step 2, complete the table. When f of x equals 1 divided by x, the vertical and horizontal asymptotes are x equals 0, y equals 0. Our reference points are these. When g of x equals 3, parentheses 1 divided by x plus 1 minus 2, our asymptote is -1 because that makes it 0, and y equals -2 because that's here. And then here we have -1 minus 1, comma 3, parentheses -1 minus 2 gives us the point -2, -5 as a reference point. And 1 minus 1 times 3 times 1 minus 2 gives us a reference point of 0 times 1. All right, go ahead and finish up step 2. All right, step 3 continued, or I'm sorry, question 9 continued. Step 3, find the domain of g of x. The domain of g of x is x is less than -1 or x is greater than -1. Set notation is x such that x does not equal -1, and interval notation is -1, comma negative infinity, comma -1, or -1 to infinity. Step 4, find the range of g of x. Inequality is y less than -2 or y greater than -2. Set notation is y such that y does not equal -2, and interval notation is -infinity, comma -2, or -2 to infinity. All right, so now we're going to graph g of x equals 3, parentheses, minus 2. Now, we first need to find the asymptotes, and we ask ourselves, what do you add to 1 to give you 0? Well, x equals -1, and then we know that this is y equals -2 is our, okay? So x equals -1, we have a vertical asymptote right here, and y equals -2. Okay, now let's graph this and points Control T. Okay, tab, delete this, 3, parentheses, Control divide 1 divided by x plus 1 minus 2. Now, again, it looks like we don't have an exact point, so we're going to have to get the approximate value. So Control T. We want to find the vertical asymptote. There it is right here. And we want to use the points, and that shows you where we get the reference points from the table. So we're going to use the point 0, 1, and -2, -5. So if you didn't understand how to get these points from the table, don't worry, you can get those points from the graph. They're to the left and right of the vertical asymptote. Okay, so 0, 1 is right here. Okay, now we know it lies between these curves, so then -2, -5 is right here. We know our curve lies between the asymptotes. It's right there. All right, go and finish up step 5. All right, and I believe that completes question number 9. So now let's take a look at question number 10. Identify the transformations of the graph of f of x equals 1 divided by x that produces the graph of the given function g of x. Then select the graph of g of x by applying the transformations to the asymptotes x equals 0 and y equals 0 to the reference. Points -1, -1, and 1, 1. Also enter the domain and range of g of x using inequalities, set notation, and interval notation. Where g of x equals parentheses 1 divided by -0.5 parentheses x minus 3 plus 2. Step 1. The transformations of the graph of f of x that produce g of x are a horizontal stretch by a factor of 2, and that's because of the 0.5. The reflection across the y-axis, that's because of that negative right there. The translation of 3 units to the right, that's because of this right here. And then up 2 units, or 2 units up, is because of that. All right. Step 2, complete the table. Okay. When f of x equals 1 divided by x, the asymptotes are x equals 0, y equals 0, and the reference points are -1, -1, 1, 1. When g of x equals parentheses 1 divided by -0.5 parentheses x minus 3 plus 2, x equals 3 because of that right there. That's 3 minus 3 gives you 0, and y equals 2 because of that right there. Don't worry if you don't understand the algebraic part of getting the reference points. I'll show you how to get them in the table in a second. Okay. All right, finish up step 2. All right, step 3. Find the domain of g of x. Okay. Domain of g of x. Inequality is x less than 3 or x greater than 3. Set notation is x set x does not equal 3, and interval notation is -infinity to 3 or 3 to infinity. Find the range of g of x. Inequality is y less than 2 or y greater than 2. Set notation is y such that y does not equal 2, and interval notation is -infinity to 2 or 2 to infinity. Now let's graph g of x. All right, so first off, we ask ourselves, what do you subtract from 3 to give you 0? The answer to that is x equals 3. And then the plus 2, y equals 2. So those are your asymptotes, okay? So x equals 3. And then y equals 2. Okay? All right, so now let's graph. So Control T, tab, delete this, parentheses, Control divide 1 divided by -0.5, parentheses x minus 3. Click to the right once, twice, 3 times, plus 2. And we want, this point doesn't look exact. That does. So let's go ahead and do Control T. So you know what? We can actually use this point and this point. So let's use the point 2, 4, and then 4, 0. When in doubt, use the point to the left and to the right of the vertical asymptote. All right, so 2, 4. So 2, and then 4 is right here. And as long as you have the point, you know that the curve lies between the asymptotes. So you have this. And then 4, 0 is right here. And again, once you have the point, you know it lies between the asymptotes. The curve is right here. All right, that finishes up question number 10. All right. Let's move on to question number 11. All right. Identify the transformations of the graph G of X, or f of x equals 1 divided by x that produces the graph of the given function G of x. Then select the graph of G of x by applying the transformations to the asymptotes x equals 0 and y equals 0 to the reference points -1, -1, and 1, 1. Also enter the domain and range of G of x using inequality set notation and interval notation. So G of x equals -0.5 parentheses 1 divided by x plus 3 minus 1. Step 1. The transformations of the graph of f of x that produce G of x are vertical compression by a factor of 1/2. That's because of the 0.5. The reflection across the x-axis, that's because of this right here. A translation of the units to the right, that's because of this right here. And then 1 unit down, that's because of this right here. All right, let's move on to step 2. All right, step 2. Find the domain of G of x. The domain of G of x is the inequality x less than 3 or x greater than 3. Set notation is x such that x does not equal 3. And interval notation is -infinity to, that should be a positive 3. Or 3 to infinity. Find the range of G of x. Y is less than -1 or y is greater than -1. Set notation is y such that y does not equal -1. And interval notation is -infinity to -1 or -1 to infinity. All right, let's graph G of x. Okay, first of all, asymptote. Well, we ask yourself, what makes this 0? Well, x equals 3. And then y equals -1. Okay, so let's go ahead and graph our asymptotes. And then y equals -1. Okay, and let's go ahead and graph that. So Control T, Tab, delete this. Oh, if that ever happens, just press Escape. And then -0.5 parentheses, Control divide 1 divided by x minus 3. Draw it once, twice, -1. And it doesn't look like we have exact points, so we're going to press Control T. And we're going to pick the values to the left and right of the asymptote. So 4, -1.5, and 2, -0.5. Okay? So 4, -1.5. So 4, -1.5 is here, which tells us the curve lies between here. And then 2, -0.5 is right here, which tells us the curve lies between here. Okay, go and finish the graph for question number 11. All right. Take a look at question number 12. Identify the transformations of the graph of f of x equals 1 divided by x that produces the graph of the given function G of x. Then select the graph of G of x by applying the transformations to the asymptotes, x equals 0 and y equals 0, to the reference points -1, -1, and 1, 1. Also enter the domain and range of the G of x using inequality set notation and interval notation. So G of x equals 1 divided by 2 parentheses x plus 3 plus 2. The transformation of the graph of f of x produces G of x. A horizontal compression by a factor of 1/2, that's because of this 1/2 right here. A translation of 3 units to the left, that's because of this right here. And 2 units up, that's because of this right here. Okay, finish up step 1. All right. Step 2, find the domain of G of x. Inequality is x less than -3 or x is greater than -3. Set notation is x such that x does not equal -3, and the interval notation is -infinity to -3 or -3 to infinity. Step 3, find the range of G of x. Inequality is y is less than 2 or y is greater than 2. Set interval is y such that y does not equal 2, and the interval notation is -infinity to 2 or 2 to infinity. All right, step 4, graph G of x. All right, so we need to find asymptotes. Well, we asked what do we need to do to make this 0? Well, -3 plus 3 is 0, so x equals -3, and then y equals 2 because of that right there. Okay, so x equals -3, and then y equals 2. Okay, so now let's graph this. Control T, tab, delete this. So control divide 1 divided by 2 parentheses x plus 3, click to the right once, twice, plus 2. Okay, these don't look like exact points, so let's press Control T. Find the asymptotes. There it is. So we're going to use the points -2, 2.5, and -4, 1.5. When in doubt, use the points to the left and right of the vertical asymptote. All right, so -2, 2.5. So 2.5 is right here. So that means our curve is right here. And then -4, 1.5, -4, 1.5 is right here. So our curve lies right here. All right. All right, go ahead and finish the graph up for question 12. All right, let's take a look at question 13. All right, enter the functions whose graph is shown. Use the form g of x equals a, parentheses 1 divided by x minus h plus k. Use the graph to find the asymptotes h and k. Okay, so our h value asymptote is right here. So h equals 3. Okay, and then our k value is right here, which is 3. Okay. Substitute the points 2, 0 and the vertex 3, 3 into g of x equals a, parentheses 1 divided by x minus h plus k. So this is x, this is y, this is h, this is k. So, and when I say y, we can also say that's g of x. So that's 0 equals, we don't know a, parentheses 1 divided by x, which is 2, minus h, which is 3, plus k, which is plus 3. All right, let's move on to step 3. Okay, solve for a when 0 equals a times parentheses 1 divided by 2 minus 3 plus 3. Okay, so we have 0 equals a, parentheses 1 divided by 2 minus 3 is -1 plus 3. Okay, well, 1 divided by -1 is -1, so that's 0 equals a times -1 plus 3. Let's go ahead and subtract 3 from both sides. So -3 equals a times -1. But we know that a times -1 can be written as -3 equals -1a. Divide both sides by -1. So then 3 equals a. So our equation, okay, we know that h equals 3, k equals 3, and now a equals 3. Well, that makes it fun. We plug that into y equals a, parentheses 1 divided by x minus h plus k. So y equals 3, parentheses 1 divided by x minus 3 plus 3. All right. Let's take a look at question number 14. All All right. Enter the function whose graph is shown. Use the form of g of x equals a parentheses 1 divided by x minus h plus k. Use the graph to find the asymptotes. Okay. Real simple. Our asymptote, it looks like h equals is right here. So that's -3. All right, and then k is right here. Which is -4. Okay. All right, substitute the points -4, -2 in the vertex -3, -4 into g of x equals a parentheses 1 divided by x minus h plus k. Now this is x, this is y, but y equals g of x. So that's -2 equals, we don't know a, parentheses 1 divided by x, which is -4, minus h, which is, this is h, this is k, minus a -3 minus 4. All right, let's move on to step 3. Step 3, solve for a when -2 equals a parentheses 1 divided by -4 plus 3 minus 4. And you're probably wondering, well, what happened with this plus 3? Well, if I go back, when you subtract a negative, that becomes positive. Okay? All right, now let's solve for a. Okay, so we have -2 equals a parentheses 1 divided by -4 plus 3 is -1 minus 4. Well, that's -2 equals a. 1 divided by -1 is -1 minus 4. Add 4 to both sides. -2 and 4 is 2 equals -1 and a is -1a. Divide both sides by -1. So -2 equals a. Okay, so now we have a equals -2. We know that h is -3 and k is -4. We know the equation is y equals a parentheses 1 divided by x minus h plus k. So we plug those in. So y equals -2 parentheses 1 divided by x minus a -3 minus 4. But we know when you subtract a negative, that becomes positive. All right, go ahead and finish up question 14. All right, question 15. Select the transformation of the graph of the parent rational function that result in the graph of g of x equals, this should be a division sign, 1 divided by 3, parentheses x minus 2 plus 1. Okay, we have a horizontal compression by a factor of 1/3. That's because of the 1/3 here. We have a translation up 1 unit. That's because of here. And then a translation to the right because of that. All right, go ahead and finish up question 15 and go ahead and finish up your assignment and have a wonderful Wildcat day.